All right, thank you everyone for joining us today for our webinar series. We're excited to see you all again. Our speaker today is Dr. Leila Rashidi, and she'll be discussing threat intelligence sharing in her presentation. Dr. Rashidi is a postdoctoral fellow at the Canadian Institute for Cybersecurity, CICS, located at University of New Brunswick. She currently leads an R&D project, a research and development project in collaboration with IBM. Prior to joining the Canadian Institute for Cybersecurity, CICS, she was a postdoctoral associate at the Department of Computer Science, University of Calgary for 2 years. She holds a Ph.D. in computer engineering from Sharif University of Technology. She was also a visiting scholar at CICS, University of Massachusetts in Amherst in the United States from August 2017 to March 2018, and Department of Electrical and Electronic Engineering at the Imperial College London, England from November 2018 to February 2019. Her research focuses on cybersecurity, performance evaluation, networking, and cloud computing. And for our audience, if you have any questions, please feel free to put it in the Q&A box below at the bottom of your screen, and we'll read them out at the end of Dr. Rashidi's presentation. Dr. Rashidi, the floor is yours, please.
Thank you, Awala, for introducing me. Let me share the screen. Hi, everyone. I'm so happy to talk about threat intelligence sharing, which is very important weapon in cybersecurity today. The outline of my presentation is included in this slide. First, I talk about what is threat intelligence, what are benefits of threat intelligence sharing, what we need to share, and what we gain with sharing. And then I emphasize on importance of automation for sharing cyber threat intelligence. Then I talk about some concerns or drawbacks of sharing cyber threat intelligence, some protocols and languages that are used for sharing threat intelligence are explained in this presentation, especially STIX is introduced in more details. Then sharing models will be presented, and then I talk about threat intelligence sharing platforms that organizations can use. And then I refer to global statistics for CTI sharing. And at the end, I talk about some details about MISP platform, which is a threat intelligence sharing platform. Cyber threat intelligence refers to the knowledge, skills, and information derived based on experiences about the cyber incidents and assessment of threats. This is called intelligence. It's not a simple information because it is a kind of information that has been analyzed and we can take action based on that. CTI, because CTI includes various attributes which are very important, like descriptions of threat actors, campaigns, motivation, and indicators of compromise. For example, if we know what is the threat actor, so we can take some actions in order to mitigate or prevent the potential attacks. When cyber threat intelligence sharing is considered as a cybersecurity secret weapon to proactively mitigate nowadays cyber attacks, which are so complicated, especially because of AI and machine learning. When you participate in a community and you share cyber threat intelligence, you will gain shared situational awareness, and also the collaboration between partners will result in agility to take action against a threat. Cyber threat intelligence sharing results in faster identification and detection of threats, threat actors, and also related tactics, techniques, and procedures. If there is any ongoing attacks related to the threat, you can better and faster mitigate the attack. And also, if attack has not happened yet, you can avoid attack. And avoiding potential attacks is very important for the companies and organizations, because when a cyber attack hits a company, it impacts negatively on the reputation of the company and also brand. When you avoid a cyber attack, cost will be much less than mitigating an ongoing attack. And also, when you are able to avoid any attack, so you can continue your service to the customers. This is very important in perspective of economic. In the past, CTI was shared manually using tools such as email, phone calls, meetings, shared databases, web portals, and also data feeds. In the next slide, I present to you why we need automation, and the manual CTI sharing is not applicable in nowadays. We need automation to share cyber threat intelligence because of a scarcity of security experts, because we need to deal with big data. Data is generating, and the volume of data generated per day is very large. And also, we need time efficiency, and timing is very important. So automation is the key to successfully share cyber threat intelligence. Particularly, automation simplifies and speeds up the sharing process and documentation. And also, when you automate the sharing process, you decrease and minimize the human errors like miscommunication. So I can conclude in this way that automated data analysis, collaboration, and sharing of cyber threat intelligence are needed to tackle with current and future cyber attacks. And the role of human analysts is that they can support systems for automated CTI exchange analysis and decision making. In the literature, there are three models for sharing cyber threat intelligence. One of them is peer-to-peer, in which two stakeholders directly share the cyber threat intelligence with each other. The first figure in the top of this slide refers to peer-peer. The second figure refers to peer-to-repository sharing, which is the second sharing model. In that model, there is a repository, and several stakeholders write their cyber threat intelligence in the repository and read cyber threat intelligence of other stakeholders from that repository. And the hybrid approach, you can directly share the cyber threat intelligence between a stakeholder or use a repository. Given the benefit and important advantages of the cyber threat intelligence, there are some concerns with that cybersecurity weapon. One of them is privacy and liability concerns. Another is that you may share CTI with unauthorized stakeholder, and also some organizations have a concern that if they share their cyber threat intelligence, they will be targeted by the attacker. If attackers know that they are active in CTI sharing, they can perform an attack against them. And especially when you share CTI with competitor companies, that results in free riding for the competitor companies, and also this may be discouraging for the stakeholders. Also, I can refer to negative publicity, which results in the negative impact on the market value and stock price, and finally distrust. Now, I talk about protocols and languages that are used to share cyber threat intelligence. There are two widely accepted protocols accepted in the cybersecurity community. One of them is STIX, which stands for Structured Threat Information Expression. It is written in a JSON file, and it is human and machine readable. The second one is a TAXII, which stands for Trusted Automated Exchange of Intelligence Information, and it is an application protocol for exchanging cyber threat intelligence over HTTPS. There are also other protocols that are less used, like Open Threat Partner Exchange or OpenTPX. It is open source and machine readable in a JSON format. The other is malware attribution, enumeration, and characterization. This is based on XML format, and also, fortunately, it is human and machine readable. And the other is incident object description exchange format based on XML, and it includes structured information about computer security incidents. And finally, vocabulary for event recording and incident sharing. This also includes descriptions about security events and also security incidents. Now I provide more details about STIX language. It is an open source and free language for the exchanging cyber threat intelligence. STIX has three core objects, three kind of core objects. One of them is domain objects, which provides high-level intelligence to represent behaviors and constructs. The other core object is cyber observable objects, which describes some observation about entities like network connection, host, and other things. And we have also relationship objects that are used to connect cyber observable objects with domain objects. In addition to these three core objects, there are two other objects in the STIX. One of them is meta objects, which provides metadata in order to enrich STIX core objects. And also there is a bundle object. Bundle object used for packaging the STIX content together. It provides, it acts as a wrapper. Now I introduce some domain objects in STIX 2.1. One of the domain objects that is very important in cybersecurity is attack pattern. It refers to a set of tactics, techniques, or procedures, TTP, that describes a way that attack perform and attacker targets some entity to compromise it. Another domain object is campaign. Campaign versus attack pattern refers to a group of adversarial behavior or a set of malicious activities or a set of attacks. For example, I can refer to a campaign in order to find the credential and then access to the system and then do lateral movement and then compromise the domain controller of an organization. So campaign refers to a set of malicious activities or attacks that occur subsequently over a period of time. I think it can be referred to as a plan with a special goal. The other object is identity, in which the identity of actual individuals, organizations, or groups are described. We have a location object as a domain object in STIX, and malware analysis objects include some metadata and results obtained after analysis of a malware or malware family. And at the end, we have observed data. Observed data objects provides additional context about the cyber observable object. For example, cyber observable objects includes the raw data for the observation, but observed data, domain objects, refers to the time of the observation and other details. Here you can see an example of an campaign object. You can see that the type of object is written as campaign. We have an ID, then version of the STIX is included. We have two timestamps. This is the time that object is created and the time that object that refers to the last modification of the objects. Then we have a name for the campaign. For example, it is Green Group Attacks Against Finance. And then more details are provided as a value of the description attribute. Now I talk about threat intelligence sharing platforms that automate some functionality to share the cyber threat intelligence. There are several threat intelligence platforms that some of them are open source and you can use for general CTI sharing. One of them is Malware Information Sharing Platform or MISP, Threat Connect, IBM X-Force Exchange, Anomaly, Facebook Threat Exchange, CrowdStrike, and also Electric IQ. And if you look at the global statistics on 2020 and 2021, you can see that using threat intelligence platform has a very important role to share the threat intelligence, and it is used by many companies. According to the survey conducted in a study, you can see that 40% of the respondents were using vendor-created threat intelligence platform, and also 39% of them in 2021 were using open source threat intelligence platform. And you can see that the percentage related to using a threat intelligence platform increases from 2020 to 2021. For example, we see a 2% increase in using open source threat intelligence platform, but the share of manual cyber threat intelligence sharing is more than the automated threat intelligence sharing, according to this survey. Now I describe more details about a cyber threat intelligence sharing platform called MISP. MISP is open source and can be used to share indicators of compromise, financial fraud information, and counterterrorism information. And it is used by thousands of organizations belonging to different domains, ranging from NATO agencies, Ministry of Defense, computer security incident response team communities, and also private sector actors. MISP instances act as a repository that includes the cyber threat intelligence of an organization or company, and it can be installed on any standard Linux distribution. A MISP instance can be considered as an independent centralized server that in which CTI are stored, and then it will be shared by a defined set of participating organization or sharing partners. And MISP instances can be standalone or they can connect to other MISP instances. And when they connect with other MISP instances, according to some defined synchronization mechanisms, the CTI stored in each instance will be shared with the other instances, and it can be in one or both direction between connected instances according to the user-defined distribution settings. Now with an example, I show how MISP works. For example, look at this figure. You can see that we have an organization called Organization A. It has a MISP instance, and also we have a community for these organizations. Organization B and Organization C are two members of these communities. The CTI shared by organization A are shared in two ways. One of them is shared with only within the community, and the other is shared with connected communities. For example, the solid circuit shows the information that can be shared with connected communities, but other information should be shared only with organization B and organization C. So when organization B receives some CTI labeled with shared as a connected communities, they will be shared in the community of organization B. As you can see in this figure, organization F is a member of community of organization B. So organization F receives that information, but it cannot transfer it to organization E, because it can be shared only one community further. And as a conclusion, in this talk, I covered the advantages of benefits and of cyber threat intelligence sharing. It is very important to proactively mitigate the attacks and prevent them, especially nowadays that cyber attacks are very complicated and can be too costly. I introduced some well-known protocols and languages such as STIX, TAXII, OpenTPX in this talk, and also I showed some objects available in STIX that you can use for describe different information about threat actors, and also TTPs. There are some platforms that can be used to share CTIs between organizations and companies. Some of them are open source, and you can define the organizations that you want to share the CTI with them, and then it can be done automatically based on the rules or synchronization mechanisms that you define. And almost any other method in cybersecurity, CTI sharing also has some drawbacks, and people have some concerns, such as free riding for competitor sharing partners and also privacy violation. This is the main references that I used to prepare this talk, and thank you for listening. If you have any question, I can answer.
Thank you very much, Dr. Rashidi, for the wonderful presentation. I believe our audience have learned a few things about threats today. We have one question here. It reads, given that sharing CTI is very risky, what happens if the CTI is shared with a malicious partner or an adversary?
I think, yes, I agree that sharing CTI with an adversary or malicious partner is possible, but there is a trade-off between not sharing and sharing. When you share, you can also gain more information, more awareness about the threats. And I think any company or organizations, based on the situation of the organization and also the category of the threat that it founds, it can decide to share and not to share. For example, if you consider, I don't know, Ministry of Defense, so I think that they will not be willing to share CTI information, because it is very secret department, and it will be too risky, and they cannot tolerate sharing that. But there is a trade-off, and I think most of organizations and companies can share CTI information with other partners which are trusted to them. It's related to sensitivity of the data, and also what organizations we are talking about.
All right, thank you, Dr. Rashidi, for the wonderful presentation. I believe we have all learned something new today, and we hope to see you again soon. Thank you very much.
You're welcome. Thanks for listening.
All right, thanks. Bye-bye.
Thanks. Bye.